Good day, everyone. I am Karylle Elliaca, and I am your first reporter for this day. We're going to discuss about codes. So, what do you mean by code? In information and communication processing, code is a system of rules to convert information into another form. Binary coding schemes. The alphabetic data, numeric data, alphanumeric data, symbols, sound data, and video data are represented as combinations of bits in the computer. The bits are grouped in a fixed size, such as 8 bits, 6 bits, or 4 bits. A code is made by combining bits of definite size. Binary coding schemes representing the data such as alphabets, digits from 0 to 9, and symbols in a standard code. A combination of bits represents a unique symbol in the data. The standard code enables any programmer to use the same combinations of bits to represent a symbol in the data. Coding schemes. Coding schemes is a set of codes or convention that associate each character with character set with a unique bit pattern a binary representation of the integers from 0. So, there are three common coding schemes. First is the ASCII, next is the EBCD code, and third is the Unicode. ASCII code, or the American Standard Code for Information Interchanges, is widely used in computers of all types. And ASCII codes are of two types, the ASCII 7 and the ASCII 8. When we say ASCII 7, it has a 7-bit standard ASCII code. In ASCII 7, the first 3 bits are the zone bits and the next 4 bits are for the digits. ASCII 7 allows 27 equals 128 combinations. 128 unique symbols are represented using the ASCII 7, and it has been modified by the IBM to ASCII 8. ASCII 8, it is an extended version of ASCII 7. ASCII 8 is an 8-bit code having 4 bits for zone and 4 bits for digits. ASCII 8 allows 28 equals to 256 combinations. ASCII 8 represents 256 unique symbols, and it is used widely to represent data in computers. So unlike sa ASCII 7 mayroong 3 bits for zone while sa ASCII 8 mayroon siyang 4 bits for zone. ASCII 8 code represent 256 symbols. Codes 48 to 57 stands for numeric from 0 to 9. Code 65 to 90 stands for uppercase letter from A to Z. Codes 97 to 122 stands for lowercase letter from A to Z also. Codes 128 to 255 are the extended ASCII codes. Now, I will show to you a video on how to convert a word into binary digits.
So in this problem, we are given a partial ASCII table. This is not the whole thing. And we're asked to convert the word blue to binary. So let's go ahead and do that. Let's make a table that will make this a lot easier for us. So we have the letter, the decimal value, and then the binary value that's going to correspond to that. So the first letter is going to be B, and then L, and then U, and then E. Now we need to pay attention to the capitalization. Capital B has a decimal value of 66. And then lowercase l has an ASCII decimal value of 108. And then U has a value of 117. And then E has a value of 101. So these are the letters that you'll find in a keyboard. Now the next thing that we need to do is convert the decimal values into binary values. Now the ASCII code is a 7-bit binary system. So 2 to the n minus 1, or 2 to the 7 minus 1, that's 2 to the 6, which is 64. 64 is going to be the highest placement for the binary numbers. So it's going to be 64, 32, 16, 8, 4, 2, and then 1. So to get 66, we need to add up 64 and 2. So we're going to put a 1 for those values. It's 1, 0, 0, 0, 0, 1, 0. So that is the binary equivalent of 66. So the letter B corresponds to the 7-bit binary code that we see here. Now let's move on to the next one. So the letter L has a decimal value of 108. To get 108, we need 64, we need 32, so that's 96. Now, if we add 16 to 96, that's going to be 112, which is too much. Since we don't need a 16, we're going to put a 0. Now, we do need an 8. So we have 96 plus 8, that's 104. We only need 4 more to get to 108. So we'll put a 1 on the 4 and a 0 for the 2 and 1. So that is the 7-bit binary code for the letter L. Now for U, which is 117, we need the 64, the 32, so that's 96. If we add 16 to 96, that'll give us 112. So we need 5 more. To get the 5, we need to use a 4 and a 1. So that is the binary equivalent of 117. If you add up 64, 32, okay, I'm not sure what just happened there. Sometimes this computer acts up. But if you add 64, 32, 16, 4, and 1, that'll give you 117. Now, for the letter E, we need to get 101. So we need to add up 64, 32, that's 96. So we only need 5 more to get to 101. So we're going to use the 4 and the 1. So that's the binary code for the letter E in the ASCII table. So thus we have this. The word blue has the binary codes 1, 0, 0, 0, 0, 1, 0, and then for L it's 1, 1, 0, 1, 1, 0, 0, and for U it's 1, 1, 1, 0, 1, 0, 1, and finally for E 1, 1, 0, 0, 1, 0, 1. So that's how you could use the ASCII table that was given to you to convert a word into binary. Now, let's work backwards. So using the ASCII table shown below, convert the following binary coded message into a word. So feel free to pause the video and try this example problem. So first, let's get the decimal equivalent of each binary code. So this is going to be 64, 32, 16, 8, 4, 2, and 1. You know what? Let me write this better. I'm going to have to space out these values. So you won't get confused. So we have a 64, we have an 8, and we have a 4. So if we add those numbers, 64 plus 8 plus 4, this is 76. And 76, looking at the ASCII table, corresponds to the letter L. So that's the first one. So now let's move on to the second code. It's 1, 1, 0, 0, 1, 0, 1. So we have a 64, we have a 32, a 4, and a 1. So 64 plus 32 plus 4 plus 1, and that is 101. and 101 corresponds to the letter E. So we have a lowercase e. Now let's move on to the next one. So it's 1, 1, 0, 1, 1, 0, 1. So we have a 64, a 32, an 8, a 4, and a 1. 64 plus 32 plus 8 plus 4 plus 1. So that's going to add up to 109. And 109 corresponds to the letter M. So you could probably figure out what word this is going to. Now let's move on to the next one. So we got 1, 1, 0, 1, 1, 1, 1. So we have everything except 16. So it's 64 plus 32 plus 8 plus 4 plus 2 plus 1. And so that is 111. So 111, that's O. And now for the last one. 1, 1, 0, 1, 1, 1, 0. So we have everything except 16 and 1. So it's 64 plus 32 plus 8 plus 4 plus 2. And that is 110. And 110 is N. So the binary code corresponds to the word lemon. So now you know how to use the ASCII table. You know how to interconvert between the ASCII code and a binary code.
Next is the EBCDIC, or the Extended Binary Coded Decimal Interchange Code. EBCDIC uses 8 bits, 4 bits for zone and 4 bits for digits, to represent a symbol in the data. EBCDIC allows 28 is equals to 256 combinations of bit. 256 unique symbols are represented using the EBCDIC. It represents decimal number from 0 to 9, lowercase letter from A to Z, and also uppercase letter from A to Z, and these are mainly used in the mainframe computers. So, given below is the EBCDIC tabular column. As I've already said, EBCDIC code is an 8-bit code that defines 256 symbols. For example, dito sa alphabetic, letter A corresponds to the code 1100000001. And also, dito sa special character, itong plus sign, it corresponds to the code 01001101. Next is the Unicode. Unicode is a universal character encoding standard for the representation of text, which includes letters, numbers, and symbols in multilingual environments. It uniquely represents a symbol in the language like China and Japan. It has 32 bits and allows 232 approximately 4 billion combinations. It is compatible and identical to ASCII 8. It is implemented by character encoding and commonly used encoding schemes. Unicode can uniquely represent any characters or symbols present. Other languages include in the Unicode standard are the English, Arabic, Greek, and even Cyrillic. Symbols are also included and it corresponds to a code. Next is the binary code. Binary code is the simplest form of computer code or programming data. A binary code represents text, computer processor's instructions, or any data or any other data using the two symbols. The two symbols used is often 0 and 1 from the binary number system. It is represented entirely by a binary system of digits consisting of string, of consecutive zeros and ones. Binary code is often associated with machine, a computer, or other piece of hardware. Binary number system. Binary number system is a numbering system that represents numeric value using two unique digits, 0 and 1. Most computing devices use binary numbering to represent electronic circuit voltage, state, or the on and off switch, which consider 0 voltage input as off and 1 input as on. This is also known as the base 2 number system or the binary numbering system. Binary file, also called binaries. It is a type of computer file that is used to store binary data. It may contain any type of formatted or unformatted data encoded within binary format. It is used directly by the computer and generally cannot be read by human. A binary file may consist of binary data stored by the computer or non-binary data converted or encoded into binary data. A binary file generally remains native and resident within the computer, pero maaari din siyang i-convert or i-encode to plain text if kailangan siyang i-transmit over network or internet connections. A computer program file is one of the most common example of binary file. Next, we have binary digits. As I've already said, bit is the short for binary digit. Binary digit is the smallest unit of information in a computer, used for storing information and has a value of true or false, or on and off. The value of a bit is typically stored above or below an allocated level of electrical charge within a capacitor inside a memory module. For devices that use positive logic, value 1, true value or high, is positive voltage relative to the electrical ground, and value 0, the false value or low, is a 0 voltage. The value 0 and 1 also may be inferred as logical values like yes and no or true or false.